Hello, folks. We're back. We are now going to dive into something that uses our existing knowledge of alternating series to ask two different questions. So this video is going to cover the first question, which is to talk about something called the radius and the interval of convergence. So what does that mean? Well, we're going to add something in. We're going to have a different type of series that you haven't seen before. We're going to say this is what it looks like. We still have this, oops, sorry, that should be n. So we still have this n to infinity, right? 0 to infinity. I'm starting at 0 this time. And we still have n, but we're going to add something new. We're adding an x. You might say, well, what's going on with this x here? Well, that x is another variable, the other variable that kind of helps determine whether or not this series is going to converge or diverge. Now, if x was 1, you would know that this series is going to converge. But the question that we're going to ask is about when there's other values, right? There's other values of x, and the question is, for what values of x will this converge? We can kind of start seeing what this might look like. And we say, well, what would this look like? Let's plug in some numbers. We plug in 1. We're going to get, I think, what? 1/4 x. We plug in 2. We're going to get 2 times 2 over 16, which is what, 1/8 times x squared. Plug in 3. We're going to go at 3 over 64 x cubed. We'll do one more. What, 4 over 4 to the 4th. That's 4 cubed. That's 64. Okay. So this keeps going, right? Now, if you think about x being really, really small, say like x was a minuscule fraction, you're going to see, wow, that's getting close to 0 pretty fast. It definitely feels like it's going to be getting really, really, really small, right? So if like x was like 1/10, you're like, oh yeah, that's going to converge. But there's got to be some values of x. Like if x was like a million, and you're like thinking a million to the 4th, it's probably not going to converge. So what we have to ask the question is, for what values of x will this converge, and for what values of x will this not converge or diverge, right? So we have to think about that. And the way that we're going to do this is we're going to do the same test that we usually do. We're going to, think about what a test that we can do. It's going to ask the question, when is this going to converge? So whenever I have kind of n and 4 to the n, an exponential function, my first go-to is the ratio test. So that's what I'm going to employ here. I'm going to use the ratio test. So what we're going to say is rho is going to equal the limit as n goes to infinity of the next term, that's the n plus 1 term, over the nth term. And if we rewrite this a little bit, it doesn't, I've done this stuff before, so I hope that I'm not going out too far on a limb when I change this. Right? So that's if you move the fraction around. And once you move the fraction around, you're going to get nice clean. And that's going to equal 1, right? The first one's 1. Next one is going to just be x. Next one's going to be 4. Right, so that's what we have. And I forgot to do this too. I probably mentioned this before. I hope I mentioned this before. Let's see if I did. Yeah, I did. Good. Okay, so the absolute value is kind of necessary because I told you in the future that you're going to have possible negative values, and yeah, that happens here. So I should have had an absolute value here. I should have had an absolute value there. So this is actually going to just equal the absolute value of x over 4. Now, when does this converge? Well, converge is when rho is less than 1. So therefore, it's converge when the absolute value of x over 4 is less than 1, right? Okay, great. So we know that when this absolute value of x is less than 1, we have convergence. And we can rewrite this as, that's just an absolute value equation, right, folks? That's algebra 2, maybe algebra 1. So that means this here is our interval of convergence. It's not a complete interval of convergence because we have some more work to do, but from -4 to 4 is effectively how, the interval that we know, anything in between there is going to converge. And it kind of makes sense, right? Because if x is small, we said that this is going to approach 0 quickly, but if x is too large, this ratio is going to be greater than 1. So this is when this converges, and this interval is kind of 8 wide, right? You think about the width of this is 8, right? And there's a term that we're going to use, which is half this radius. So half of the interval width is 4. And we're going to call this the radius of convergence. The radius of convergence is half of the width of the interval of convergence. Now, often you'll see that if you have a denominator here and it's 4, you're going to say, oh, wow, isn't that just always the radius? It often will be for the stuff that we're working at, but sometimes you have a different coefficient up here for the x. So the best thing for you to do, the most consistent thing for you to do to determine the radius of convergence is to find the interval, find like the width of the interval, and then divide it in half. So the radius of convergence, if you were asked, what's the radius of convergence? You would say, well, the radius is 4. And that's another fancy way of saying that from 0 effectively to 4, or 0 to negative 4, that's how long you'd have to go to get all things that converge. Okay, now next. What about the negative 4 and 4, right? What about at negative 4 and 4? Well, that's the next step, because the next step is, in order to get a real interval of convergence, we've just kind of provided some values, but we also need to test what's happening at negative 4 and what's happening at positive 4. We're not done until we've determined, the endpoints as well. So kind of think of this as step 1, right? Step 1 is determining this interval, and step 2 is we have to test the endpoints. So we have to kind of do 2 scenarios, right? Scenario 1 is what happens if x equals negative 4, and scenario 2 is what happens when x equals 4. Okay, so we have to evaluate these separately. I'm going to do these. I'm going to hit pause. I'll be right back in a second. Okay, so I just want to save you some time with watching me write. All I did was basically plug in negative 4 for x into the first thing I gave you, and then 4 in for x in the first thing I gave you here. So we kind of have 2 separate worlds. So if we look at this here, what's going on? Well, this just becomes basically an alternating series, right? Look at what's happening, right? This goes from 0. So if you thought about this series, it's going to be 0, then negative 1, then positive 2, then negative 3, then positive 4. I mean, all I'm doing is I'm plugging in different values of n. And I notice that what's happening is that this whole sequence, right, this here, as n goes to infinity, is not approaching 0. And you know what else? Neither is this one, right? This also is not approaching 0. This series is just getting large. This is just going to like 1 plus 2 plus 3 plus 4. It gets really, really, really large. So therefore, this side here for negative 4, when x is negative 4, this diverges by the nth term test, by the divergent test, right? Diverges by the divergent test. And so does this. Right, this also diverges. So the same thing. So therefore, negative 4 doesn't work, 4 doesn't work, and therefore our interval of convergence, our final interval, is negative 4 to 4. Now, some of you are saying, well, Mr. Poprick, what was the point of that, right? You had that up here earlier, right? Well, yeah, that's a great question. Guess what, folks? Sometimes when you plug in negative 4 here, for instance, maybe if there was an n squared in the denominator instead of an n in the numerator, guess what's going to happen? You're going to have some convergence. So what might happen is that when you plug in the end point, you're going to find out the series converges. And if the series converges instead, so let's pretend we had another scenario, right, where this negative 4, when we plugged it in, created a convergence, we'd have to come over here and change this less than to less than or equal to, right? Because at negative 4, it would work. And maybe it doesn't work over here. Maybe it works on both sides. Maybe this is the final interval. Maybe if you plugged in 4, it would also work, and maybe you'd have an equal sign there too, right? So you don't know. And these two are not related, right? These two equal signs, whether they're there or not, are not related. But in this case, I'm getting a little bit ahead of my skis because that's all we have. The good news is, folks, very soon, as in the problems that you're about to do, you're going to see that sometimes the endpoint does actually converge. So make sure that will help you hopefully see the interval. See you folks in a few when we talk about errors.